Hey, welcome to Reinforcement Lens. I'm Kelvin. This channel is about one thing: decisions under uncertainty, improved by measurement, feedback, and loops. And today I want to explain why most AI agents fail. Not because the model is dumb, but because the builder forgot the boring part, the scoreboard. Imagine two people building an AI agent. Persona is the prompt wizard. They collect prompt templates like Pokemon cards. Secret phrases, prompt hacks, 10 prompts that unlock genius. They treat prompts like magic spells. Person B is, honestly, kind of boring. They don't start with prompts, they start with a scoreboard. A test set, a metric, a failure log. 1 week later, Persona has a prettier demo, smooth answers, shiny UI, looks great on stage. Person B has a system that survives reality tests, metrics, failure logs. So, when real users show up with messy questions and ugly edge cases, B can measure what broke and fix it. Here's the uncomfortable truth: a prompt is just the steering wheel. It matters, sure, but it's not the engine, and it's definitely not the brakes. Reliability doesn't come from clever wording. It comes from the system behind the words. Your test set, your metrics, your guardrails, your data you actually trust, and your process for fixing failures. Let me give you a quick story. Imagine you're building an AI assistant for internal policy questions. You spend all weekend polishing one perfect prompt. On Monday, you show the demo to your team, and it's beautiful. It answers the 3 example questions flawlessly. Everyone smiles. Then a real user shows up with a messy question like, "Can I do X if the customer is in Quebec and the contract was signed last year?" Now the assistant has to juggle exceptions, outdated documents, and missing context. If your backend is weak, no tested sources, no evaluation set, no guardrails. The model doesn't become more reliable because your prompt is better. It becomes more convincing, so a stronger prompt doesn't fix a weak system. It just turns the same mistakes into smoother sentences. It's like putting a luxury paint job on a car with broken brakes. You don't get a safer car, you get a faster crash with nicer packaging. And that's why prompt obsession is dangerous. It often improves confidence, not correctness. So, what do I mean by the system? I mean 5 boring things that decide whether your AI is actually reliable or just sounds reliable. And if you're missing even one of them, prompt tuning becomes cosmetic surgery on a broken skeleton. Let me make that image concrete. It's like putting makeup on someone with a broken leg. They might look great in photos, but the moment they try to walk, reality wins. Here are the 5 parts. First, the domain model. It just means, what is the job, exactly? If you're answering internal policy questions, what counts as a policy answer? Is it a quote from the policy, a summary in plain English, a yes/no decision, or a compliance-safe response that refuses unless it has enough context? Those are totally different tasks. If you don't define which one you want, the model will guess, and it will guess confidently. Quick example: someone asks, "Can we reimburse this expense?" If the assistant is supposed to be a librarian, it should point to the exact policy section. If it's supposed to be a judge, it must say yes/no with a citation. Without a domain model, it often does the worst mix, sounds decisive but has no solid grounding. So the domain model is simply, what role is the AI playing? Second, evaluation metrics. This is where most agent projects die because people measure the wrong thing. Sounds good is not a metric. Looks fluent is not a metric. Everyone in the demo nodded is definitely not a metric. A real metric is boring and binary. Does it match the source policy? Yes or no? And just as important, can another person judge it the same way? Here's a simple metaphor. If you can't grade it, you can't improve it. No grading rubric equals no learning. Quick example. The user asks, "Can we reimburse this expense?" A sounds good answer might be confident and friendly, but your metric should be something like, did it cite the correct policy section? Yes, no. Did it follow the policy rule accurately? Yes, no. If info is missing, did it ask for the missing fields instead of guessing? Yes, no. If the reviewers read the same answer and one says correct and the other says wrong, that means your definition of correct is not real yet. And if correct isn't stable, prompt tuning becomes random gambling. Third, constraints. This is your hard boundary list, the things your system must never do, even if the user asks nicely, even if the model feels confident. Think of constraints like guardrails on a mountain road. They don't help you drive faster, they stop you from flying off a cliff. In a policy assistant, constraints look like, never invent a policy. If the policy isn't in the trusted sources, the assistant should say, "I don't know," or ask for the missing document, not guess. Never suggest illegal or non-compliant actions. If a user asks, "Can we bypass this rule just this once?" the answer should be a refusal or a safe escalation path. Never expose private data. If someone asks, "Show me customer X's details," the system should block it, no matter how well the prompt is written. Quick example. A user asks, "Can we reimburse this expense?" If the receipt type is missing, a constraint might be, "Don't approve, ask for the receipt category and policy version." Because a wrong approval isn't just a wrong answer, it's a compliance incident. So constraints are basically, what outcomes are unacceptable? Prompts try to sound smart, constraints keep you safe. Fourth, data integrity. This is simply, which documents are the truth, and how do you know? Think of it like cooking. If your ingredients are spoiled, a better recipe won't save the meal. Quick example. Your RAG system pulls an old reimbursement policy because it's written more clearly. The model answers confidently, using rules that are no longer valid. And when the documents conflict, you need a boss rule like, the newest approved policy wins, or the compliance handbook overrides team notes. Without that, the assistant will just pick whichever paragraph sounds nicer. Fifth, accountability. This is simply, when the system is wrong, who owns the fix. Think of it like a restaurant. If a customer gets food poisoning, you can't say, "Oops, nobody was in charge." Someone has to review what happened and change the process. Quick example. The assistant gives a wrong reimbursement approval and finance pays it out? Who updates the policy source? Who adds that case to the test set? Who adjusts the guardrail so it won't happen again? If nobody owns mistakes, nothing gets repaired. Errors just pile up, users lose trust, and the system rots quietly. Now let me translate this into the reinforcement learning lens, the whole point of this channel. In reinforcement learning, you don't win by making your actions sound nicer. The agent doesn't get points for being eloquent. It doesn't get points for being confident. It only gets points for one thing: does it perform better in the world? And RL has a brutally honest setup for that. It's basically a game loop. Agent gives action, gives environment, gives reward, gives update. The agent tries something, the world reacts. Then the agent gets a signal, good or bad. And that signal is what teaches it what to do next time. So here's the key idea: if you remove the reward, you remove learning. No reward means no getting better. No progress, no iteration. You can still change things, sure. You can still rewrite prompts, tweak wording, shuffle instructions. But that's not learning, that's decorating. It's like playing a video game with the score turned off. You can mash buttons all night, and you'll feel busy. But you'll never know if you're improving. So when I see prompt secrets and prompt hacks, I translate it like this: most of it is vibe-based iteration. No measurement, no scoreboard, no update signal. Just, this feels better, and our L people have a name for that. It's not optimization, it's just vibing. Let's do a tiny but real example. You're building an AI assistant for internal policy questions. You pick 20 real questions people actually ask, and you track just 2 numbers. Correctness rate, did it match the policy? Harm rate, did it confidently hallucinate or suggest something unsafe? Now here's what happens in the prompt-only world. You write prompts for 3 days. The demo sounds smoother. It feels smarter. But on the test set, the numbers barely move, or they move randomly. Let's say version 1, 11/20 correct equals 55%. Version 2, 12/20 correct equals 60%. People celebrate. We improved 5%. But with only 20 questions, that's often just noise. One question flipping doesn't mean your system improved. It might mean you got lucky. A simple way to say it. Small test sets have big uncertainty, so your improvement is smaller than your fog. Now a more brutal lens, expected value. In trading, you can be right often and still lose. If costs eat you alive, AI systems are the same. Think of each answer as a trade. You have edge, useful correctness. Cost, tokens, latency, risk, support load, reputation damage. So a simple mental model is expected value approximately equals expected edge expected cost. If your edge is tiny and your cost is guaranteed, you lose slowly, consistently. This is why so many I built an agent with RAG and afternoon projects die. And to be clear, not because RAG is useless. RAG can be genuinely powerful, but first, what is RAG in normal human language? RAG is basically this. Your AI has an open book test. Instead of forcing the model to answer only from memory, you let it look things up from your documents, policy PDFs, wiki pages, internal notes, then you paste the relevant parts into the prompt and it answers based on that. So RAG is not new intelligence. It's more like giving the model a notebook and saying, "Hey, before you answer, read these pages." That's why DMOS look amazing, because for the first time, the model can sound specific, quote things, and feel grounded. But here's the trap. Most people confuse a demo with a decision system. A demo is, I tried 3 questions. It worked, let's ship it. A decision system is, it works on messy questions, on bad days with missing info, and under pressure, and reality is messy. So, reality changes constantly. Documents update, new version, old versions still floating around. Policies change, especially compliance rules. Users are adversarial, sometimes on purpose, sometimes accidentally. Edge cases explode, the weird exceptions are the real workload. Okay. Practical part. If you want an agent that survives reality, build a minimal evaluation loop. Here's a 7-day plan. Simple, boring, powerful. Day 1. Write 10 definitions of correct, not vibes, testable criteria. Example, must cite the policy section or must refuse if policy is missing. Day 2 is where you stop living in demo land. You go out and collect 20 real cases from real users, the stuff people actually ask when they're busy, stressed, and half-explaining the situation. Not your clean, made-up examples, not the 3 hero questions you picked because they make the system look good. I mean real mess, real ambiguity, missing details, contradictions. Because if your system can't handle that, it's not an assistant, it's a stage prop. Day 3. Pick only 2 metrics. One is correctness. Did it match the policy? The other is harm. Did it hallucinate or suggest something unsafe? Keep it that simple so you actually track it every week instead of pretending. Day 4. Build an error taxonomy. Every time it fails, don't just say it was wrong. Label why. Was it the wrong policy, missing a constraint, invented facts, suggested something unsafe, or pulled an outdated source? If you can't name the failure, you can't fix it. Day 5. Add guardrails, set clear rules for refusing, require citations, and use confidence thresholds. If the assistant isn't sure, it shouldn't guess. It should say, "I don't know," and tell you exactly what information is missing. Day 6. Iterate, tune the prompt, improve retrieval, adjust tool steps whatever you want. But only one rule: measure every change on the same test set. If you keep changing the questions, you're not improving the system, you're just moving the goalposts. Day 7. Red team it, try to break it on purpose. Ask nasty questions, weird edge cases, missing info, conflicting documents. Push it the way real users will, but in a safe environment. Because if you can't break your system in testing, trust me, real users will break it in production. And that's the reinforcement lens. Not better prompts, better loops. This is my first episode on this channel, and here's the promise. Reinforcement lens is where we use math, probability, and reinforcement learning thinking to explain how the world actually works and how to make better decisions inside it. No hype, no 10 secrets, no motivational noise. Just simple models, clear stories, and systems you can reuse. Whether you're building AI, running a business, investing, or just trying to make smarter choices under uncertainty. If that's your style, subscribe. All right, see you next time.